They built an entire airport on land that didn't exist a decade ago, an island engineered from the sea. A new Earth built at a reported multi-billion-dollar cost. But beneath this new Earth, the ground is still settling, squeezed downward by hidden layers of soft marine sludge. Some satellite-based models warn that subsidence could reach 80 millimeters each year in places. The stakes are simple. If engineers can't stop the sink, this could become a permanent repair nightmare instead of a triumph of infrastructure. The real story begins with how they made the island and why the ground may never truly stand still. In Jinzhou Bay, just off the coast of Dalian, a stretch of open water transformed into solid ground. By the early 2010s, fleets of dredgers and barges began pumping sand and rock into the sea, shaping an artificial island where only waves had rolled before. The footprint is staggering, 21 square kilometers larger than some city centers. In less than a decade, this patch of ocean was filled, leveled, and sculpted to support the weight of a future mega airport. The land didn't simply appear overnight. It rose through millions of tons of fill, layer by layer, as engineers battled tides and shifting currents. Construction started in 2011, even before full national approval, a sign of the urgency to relieve Dalian's overwhelmed old airport. By 2024, the new island stood ready for its next phase, already bearing the outlines of runways and the foundations for a terminal designed to welcome tens of millions of travelers. From above, the reclaimed land stretches out in geometric precision, a man-made platform built to handle the world's largest jets. The ambition is clear: to create not just a new airport, but a new piece of China's coastline, engineered from scratch in less than a generation. Dalian's old airport, Zhoushuizi, once sat on the city edge. Over decades, the city pressed in from all sides, swallowing up open land and closing off every path for expansion. Apartment towers, factories, and highways hemmed in the runways until there was nowhere left to grow. By the early 2000s, the airport's single airstrip was handling more flights than it was ever designed for, with passenger numbers climbing past 19 million a year. 5 rounds of upgrades squeezed out every last bit of capacity, but the problems only got worse. Noise complaints rose as jets skimmed low over new neighborhoods. Cargo traffic jammed local roads, and even small delays rippled across the entire network. Planners studied every option: extending runways, building new terminals, tunneling under roads. But the city's relentless growth had boxed them in. There was simply no land left. When national aviation authorities reviewed Dalian's future, the answer was clear. Relief would only come from outside the city grid. The only way to break free from the urban chokehold was to look offshore, beyond the reach of real estate and traffic. That is why the plan for a new airport was not just about bigger terminals or more gates. It was about creating room to breathe by building an entirely new platform out at sea, far from the limits that had turned the old airport into a bottleneck. Imagine pressing down on a soaked kitchen sponge. At first, it feels soft and squishy, water oozing out with every push. That is almost exactly how the seabed beneath Dalian's artificial island behaves, except on a scale of millions of tons. The fill material, piled high to form the airport's foundation, sits atop layers of mud and silt that act like a giant, waterlogged sponge. When heavy weight is added, the pressure forces water out of the spaces between the tiny soil particles. But unlike a sponge on a countertop, this process takes years, sometimes decades. The ground does not spring back or instantly firm up. Instead, it compresses slowly, and the surface sinks a little more each season. The challenge for engineers is that this settling can continue long after construction. If the ground keeps compacting, runways and taxiways risk dipping or cracking. Understanding this simple sponge effect is the key to why building on soft marine sludge is never just a one-time job. It is an ongoing battle with the forces hidden below the surface. Satellites orbiting hundreds of kilometers above the Earth keep a silent watch on Dalian's artificial island. Using a technique called INSAR, they scan the reclaimed land with radar, measuring tiny shifts in elevation that would be invisible to the naked eye. Over months and years, these readings reveal a pattern. The ground beneath the airport is moving, slowly but steadily. Analysts studying this data report that parts of the new island are subsiding by 80 millimeters per year, plus or minus 25 millimeters. This is not a single snapshot, but a trend, one that matches what engineers fear most about building on soft marine sediments. Every new layer of fill and every foundation poured adds more weight, squeezing water from the mud below and causing the surface to drop. One INSAR researcher said, "We can see the land settling almost in real time down to the millimeter." These numbers are not just academic, they are the early warning system for everything that comes next in the airport's struggle to stay level and safe. Beneath the new island, the process at work is consolidation. When millions of tons of sand and rock press down on a soft seabed, the pressure forces water out of the mud below, and the ground slowly compresses. This is not a sudden collapse, it is a gradual squeeze. Water moves upward through tiny spaces between soil particles, and the land settles bit by bit. The heaviest sinking happens in the early years after reclamation, when the fill is freshest and the mud is loosest. Over time, as more water escapes and the soil particles pack tighter together, the rate of settlement slows, but it does not stop completely. Even after the surface seems stable, small movements can continue for years, sometimes decades. This lingering uncertainty keeps engineers on edge. The future of the airport depends on how fast the ground firms up, and whether the pace of sinking drops low enough to allow safe construction of runways and terminals. If the soil keeps settling too quickly, the surface could dip unevenly, threatening everything built above. To keep the ground from sinking beneath their feet, engineers turn to a toolkit built for the world's softest soils. The battle began with deep foundation treatment, 77,000 square meters of reclaimed land reinforced to take the weight of runways and terminals. In projects like this, one common method is vacuum preloading. By laying a membrane over the surface and drawing out air and water with pumps, the process squeezes the mud below, forcing it to settle and firm up in months rather than years. Another tactic often used is dynamic compaction. Heavy weights dropped again and again to shake loose sand and silt into a denser, more stable base. Where the soil is too soft, even for that, engineers rely on deep piles, columns of concrete or stone, driven down through the weak layers, anchoring structures to firmer ground far below. Each technique aims to speed up consolidation, control uneven settlement, and buy time for the airport foundations to lock in place. As one academic from Dalian University of Technology puts it, "Every day you can accelerate settlement is a day you take back from the ocean." These methods are not just theory, they are the main line of defense against the slow, relentless squeeze of the seabed, with sensors and gauges tracking every millimeter of movement as the battle continues underground. Sensors dot the reclaimed ground buried beneath runways and terminal foundations, working around the clock. Settlement plates, simple steel discs anchored deep into the fill, track how far the surface drops over time. Each plate is measured again and again to reveal if the land is settling evenly or if trouble is brewing beneath a certain stretch of pavement. Pore pressure gauges, meanwhile, are threaded into the soft layers below. These instruments measure how much water remains trapped between soil particles, a direct signal of how much consolidation is left to go. As water pressure drops, engineers know the ground is firming up, but these readings are only part of the story. In a landscape built from scratch, every number comes with caveats. Some sensors can miss sudden shifts in areas beyond their reach. Others might be thrown off by heavy rain, construction traffic, or even a change in temperature. The real test is not just in the data itself, but in how it is interpreted. Engineers pore over these numbers, looking for patterns and warning signs. Success is not measured by a single reading, but by a trend: settlement rates slowing, water pressures dropping, and the ground acting more like solid earth than a floating raft. These are the quiet victories that mark progress in a project where the enemy is invisible and always moving. The airport's ambitions are measured in phases, each one raising the stakes for what this artificial island must support. The first stage is already massive by global standards, with 2 parallel runways, each stretching 3,600 meters, and a terminal of 400,000 square meters. Depending on which official statement you read, Phase 1 is designed to handle anywhere from 31 to 43 million passengers a year, nearly double the old airport at its peak. Cargo targets in this initial build reach 650,000 tons annually, a figure that would place the airport among the country's busiest freight hubs from day one. But these numbers are only the beginning. Plans for the full build-out call for 2 more runways, bringing the total to 4, and an expanded terminal footprint that could swallow up nearly 1 million square meters. If every expansion is realized, the airport's ultimate capacity could reach 70 to 80 million passengers a year and 1 million tons of cargo. These are numbers usually reserved for the world's largest aviation gateways. Each phase locks in more weight, more traffic, and more pressure on the ground below. The prize is clear: a new gateway for Northeast Asia, built on land where none existed before. But as the scale grows, so does the risk that the ground may not keep up with the vision. Kansai International Airport in Japan stands as a cautionary tale for anyone building on reclaimed land. When it opened in 1994, engineers expected the artificial island to settle, but no one predicted just how much. Over the next 2 decades, the ground dropped more than 11 meters. That was far beyond early forecasts. Each year, the airport runways and terminals inched lower, forcing teams to jack up buildings, reinforce seawalls, and run pumps day and night to keep water out. The costs never stopped. By 2010, Kansai's ongoing mitigation had already swallowed billions of dollars, with maintenance budgets stretching into the indefinite future. A longtime airport engineer described the problem plainly. "We designed for the ground to move, but it kept moving, year after year, and every fix became part of the routine." Even today, Kansai's island still sinks, though at a slower pace, and the airport's survival depends on a permanent commitment to repairs. The lesson is clear: on soft marine sediments, settlement is not a one-time problem. It is a legacy that can last for generations, with every meter of subsidence leaving a bill that never quite goes away. Port officials in Dalian see the new airport as more than just an answer to crowded runways. They see it as a gateway that finally links air and sea freight in one seamless logistics network, connecting cargo ships and jetliners under a single plan. For a port city competing with giants like Shanghai and Incheon, the integration is a strategic bet. The payoff could be enormous: faster shipping times, new trade routes, and a surge in economic activity that ripples through Northeast China. One logistics planner puts it simply: you can't grow the port or the airport without more space. Here, we get both. Every gain comes with a cost. Marine biologists warn of risks tied to large-scale reclamation. Jinzhou Bay, part of the Bohai Sea, is home to spotted seals, an iconic species that migrates along these coasts. Regional research warns that noise, sediment plumes, and habitat loss can disrupt seal behavior and threaten local populations. Construction windows are sometimes adjusted to avoid peak migration, but the long-term effects remain uncertain. A marine scientist says, "Big infrastructure always brings trade-offs. The challenge is balancing economic ambition with the health of the ecosystem." For Dalian, the promise of a world-class transport hub is weighed against the responsibility to protect a unique marine environment. The final verdict on that balance will play out over decades as both ships and SEALs navigate the changing shores of Jinzhou Bay. Dalian Jinzhouwan Airport offshore Artificial Island reported project cost CNY 26.3 billion, approximately $4.3 billion reported. Subsidence forecast, approximately 80 millimeters per year, plus or minus 25 millimeters per year, reported and estimated from INSAR Plus modeling. Phase 1, 2 runways reported. Ground improvement, vacuum, and compaction reported. Comparison, Kansai Artificial Island precedent. Opening target 2026 reported. These are the facts as reported and modeled. An airport built on land that did not exist a decade ago. A price tag in the multi-billion range, officially CNY 26.3 billion, or approximately $4.3 billion, with some reports claiming even more. A foundation that continues settling, shrinking, and compressing as seabed mud expels water and squeezes down. Satellites can measure this movement year by year, and research using INSAR Plus consolidation modeling predicts rates on the order of 80 millimeters per year, plus or minus 25 millimeters, slowing over time. Engineers have mounted a counterattack, vacuum preloading to remove water faster, compaction techniques to densify the fill, deep foundations and other ground improvement methods are reported in project coverage. These are the defenses, yet the ground beneath remains restless. The opening target stands at 2026, but every millimeter of movement is a reminder of what is at stake. Kansai's legacy hangs over the project. That well-known artificial island airport experienced long-term settlement and required continuous mitigation. It is a warning that even the best plans can lead to decades of repairs. The challenge is simple to state and hard to solve. Can this new piece of Earth be stabilized before the first flights take off? Or will Dalian's mega airport become a permanent battle with the sea? They did not just build an airport, they built a new piece of Earth. Now they have to prove it will not keep sinking back into the sea. Right now, engineers race physics. Multi-billion-dollar ambition faces the slow, relentless force of the sea. As global coastlines sink and cities keep expanding outward, Dalian's project is more than local risk. It is a test of whether human ingenuity can truly override nature's timeline. In the end, every artificial island airport asks the same question. Can we ever build ground that will outlast the ocean? Share your thoughts below.